Welcome back to lesson 3 about pandas. In the last lesson, we learned how to load CSV files into pandas to create new data frames. Remember, data frames are just a table of values with rows and columns, with column headers and row indices. These row indices will, by default, be assigned integer values when we use the read CSV function, but they don't necessarily have to be integer values. They could be any kind of a unique index that we can assign to designate the differences between rows in our data frame. So what we're going to focus on today is how do we, just like we used to index into a list or index into a NumPy array to grab specific values, how can we get specific values or portions of a data frame? And you're going to notice that a lot of the syntaxes we work on here coincide to how we would work with NumPy ND arrays or doubly nested Python lists. They're going to look very similar, and that's just because this data frame data structure is built on top of those other tools, and so because of that, its syntax is similar but different in some important key ways that I'll try and emphasize as we go through today's lesson. Let's begin by importing pandas, like always, so that we have the library to work with. And then we'll talk about indexing, right? So now there's a lot of different data structures or data types in Python that are what's called subscriptable. Subscriptable just means I can use the index positions, 0, 1, 2, 3, 4, etc., to index into them and grab specific pieces of information. So strings are subscriptable, lists are subscriptable, but are integers subscriptable, right? So if I save these variables here by running this cell, say I wanted to grab the fourth character of this integer using square brackets, and it says int object is not subscriptable. So the reason why we bring up this new vocab word, subscriptable, is because it shows up here in error messages. And again, I want to help you understand your error messages. But what this really just means is that this is not a data type where I can use square brackets and pass in an index value to get a subset or to get a specific part of that piece of data. Now, strings are subscriptable, right? So we're getting the fifth to last character here, which is string. I can also let's grab the third character, right? So if you didn't know, strings in Python act like a list of characters, right? So I can, they're not a list, to be clear, but it's a string of characters, right? That's why we call it a string, and its values are subscriptable, very similar to how lists are. If I wanted to get from the second character to the fourth character, I can grab just a portion of a string using syntax that's very similar to list slicing syntax. In fact, it's identical to list slicing syntax. I can also index into my two-dimensional list here, right? That's something we have quite a lot of experience with. So I can grab the first item, the first list in my nested list, and then the first item in that list. So I'm getting the word another here. I can grab other items in there using different index values, string, because, why not? Another string, because, why not? So that's just a little bit of a review that we can also index into lists and nested lists, kind of just chaining on or adding on different sets of square brackets and passing index values inside of them. So what about in pandas? How do I index into a data frame and grab a specific value or subset of a data frame? First off, we need a data frame to work with. We're actually not going to read in a data frame from a CSV for some of our exercises here. We're just going to use this sales data held in this dictionary here to make our data frame. So this data frame is only going to have 6 rows by the looks of it. All right, and we have the different column headers here in bold, and we have our row indices here as these integer values in bold as well. So how can we retrieve, let's say, the value for scarf sales in January? So this value right here, how can I get at that specific value in this data frame? Well, it's almost like indexing into a two-dimensional list, but instead of giving a index value for our columns, we're just going to start with a column header and then we're going to grab the item in that column that we want. So this will give me the sales column, right? And then I want just the first value of the sales column. If I wanted the third value of the sales column, right? So on and so forth. So very much like nested lists, except instead of an index value here, I'll give a column header. Well, what if I didn't just want one value? What if I wanted the shoe sales data for all 6 months? Well, I can then just grab that whole column. By not specifying a row index, so I specify my column header, then my row index, so I specify my column header, then my row index. By not providing a row index, I get the entire column back. Good, that's all 6 values, all 6 shoe values for each of the 6 months. But like we showed before, we don't always have to use this bracket notation. I can also use dot notation and then give the column header, and that will do the same thing. I'm going to try, yet again, just to repeat this, I'm going to try and always use this square bracket syntax because there are some rare instances where this dot notation won't work. So I'm just going to try and use the approach that I know is going to work 100% of the time. All right, so we can use list slicing methods in our column, just like we would a list. One thing that's also really nice about columns is I can use list slicing syntax here to grab a subset of values in a column. So the index value that I want to start with, and then the index value that I want to end with. But remember that this second value here is exclusive. So this is only going to give me 0, 1, and 2. It's not going to include 3 as the second argument here. So let's get just the first 3 values of our shoe sales. Again, the first 3 months of shoe sales here. And these are some of the basic syntaxes. In the next section, we're going to talk about accessors, or basically the lock and iLock methods here. But before we do that, I just want to review these things really quickly and just remind you that these are not entirely new syntaxes. We're just calling them on a different data structure now. We're calling them on a data frame. But the list slicing method is something you're already familiar with. You're just doing it on a column in a Pandas data frame instead of a list or a nested list. Also, grabbing a specific value using our 2 square brackets here is almost the same. In the past, we would use 2 index positions for inside both of these square brackets. But with Pandas, we're going to access a specific column first using the column header, and then get a specific value from that column using a list position, using the row index. So this is the column index and the row index. So this 0 here also, you'll notice, corresponds to this dark left-hand index. So I'm saying I want the thing in scarves that is in row 0. So next we'll look at 2 important accessor methods that we can use to grab specific values in a data frame. So reminder, here is our sales data frame, but they follow a similar convention. So with the LOC method, I'm going to pass it a row label and then a column label, right? And with the iLOC method, I'm going to pass it a row index and a column index. That's what the I stands for in iLOC. It's based on index location is the lookup versus just the raw location, right? Let me see if I can demonstrate the differences between these 2 methods and why one might be more useful than the other. So let's look at our sales data frame. And let's use index location to grab the value of shirt sales in April, right? So here's shirts, and we want April. So we should expect to get 329.2. Well, we give it first a row label and then a column label. So this is a little bit different than we used above. Remember, above we gave it a column header as the column index and then a row index, right? Now these 2 have swapped places, and I'm going to, when I use the iLock method, I'm going to give it first a row index and then a column index. All right. So this is position 3, row 3, column 1. Row 3, column 1. All right. Also, I can use the iLock method to subset. Again, use this list slicing syntax. So what I'm going to do is I'm going to just grab the first quarter of sales for the year for all of our different items of our store here, right? So we're going to grab the quarter 1 sales by saying, give me rows 0 to 2. So I give a index value of 3 here, but remember it's exclusive. And then say, give me all of the columns, right? So this list slicing method here in one set of square brackets, separate the rows I want from the columns I want with a comma. Again, what's happening in these square brackets shouldn't be too foreign. It's something we have seen in the past. We're specifically providing this function the indices of our values. We're not giving it any column headers. We're giving it its position in this grid, rows first, columns second. So rows, then columns. So how does this differ from the .loc method, right? So what if I tried to do the same thing with the .loc method? Go from 0 to 3 on the rows and want to get all of the columns. Well, how does this differ? You'll notice that the exclusivity of this second parameter here, this list slicing syntax, is gone now because this is not based on index location. This is just based on location. So I'm getting locations 0 to 3 instead of indices 0 to 2. Right? So I get one extra row here using the .loc method than I would using the .iloc method. But there's some additional differences between .iloc and .loc that we can talk about, but they'll be a little bit easier for me to talk about after we've reviewed data frame filtering again. Remember, we showed that briefly in the first Pandas lesson, and we're going to talk about it again here, and then that'll help me show the differences between .iloc and .loc as methods for subsetting data frames a little bit more clearly. So we're going to leverage Python operators here to filter our data frame, and let's try and get all of the months where we sold at least $400 of scarves, right? So less than or equal to $400 of scarves. So let me add a code cell here. So the first thing we're going to do is remind you we can use our comparison operators in order to generate a list of Boolean values that based on that list of Boolean values, we can say which rows or columns of this data frame we want to keep or get rid of. So I can say sales.scarfs is less than or equal to 400. All right, so now I have a Boolean value. This is going to tell me that 1 and 2 are going to get saved. Now, what's happening here is this is not going to really help me demonstrate the differences between .iloc and .loc if I use this $400 scarf method. I want these true values to be mixed up. That's going to help me demonstrate things a little bit better. So let's try and look at hat sales that are greater than or equal to 120. Now this is a little bit better. They're not at the beginning of the data frame. This is going to help me demonstrate the differences between .iloc and .loc for reasons you'll see here in a minute. So let's actually use our hat sales being greater than or equal to $120 as our condition, right? So I'll save those to condition variable, pass them into my square brackets here as if I was trying to access things in this data frame based on this condition, and it will filter my data frame, right? So I only have now rows 2 and 3, which is where the true values were in my condition. All right. Now, what's really useful is I'm going to save this to a new variable. I'm going to save my filtered data frame to a new variable called filtered. And now I permanently have these two rows as a new data frame. But you'll notice that even once I save this as a new data frame to a new variable, these indices do not reset, right? So this does not reset to be 0 and 1. They stay as 2 and 3 after I have filtered my data frame. So now you'll really be able to see the differences between loc and iloc. So I want things at index location 1, 1. So that means row 2, column 2, 329.2. Well, what if I wanted to get the thing at location 1, 1? So instead of being based on index position, it'll be based on literally what is the column index here, right? So .loc11, if I try and grab it using .loc, it's going to say, what? Key error 1. What key error means is that the thing that you put inside of these square brackets doesn't exist, right? So what is this really trying to do? It's looking first for row 1, but because this data frame has been filtered, there is no row 1. We only have rows 2 and 3, right? So particularly with filtered data frames, the differences between .iloc and .loc become readily apparent. .iloc says, hey, this is the data frame we have. I'm going to say that this is index position 0, this is index position 1, likewise for columns. index position 0, 1, 2, 3, 4. And it just goes based on whatever's in the data frame, kind of reassigns its own indices, and we'll be able to look things up based on the position of cells within the data frame. Whereas .loc is specifically looking at row indices, these bold values on the left-hand side of the row, and is doing its lookups that way, right? So if I have a filtered data frame that has no column with this row index of 1, this will break because as it tries to look up row index 1, it can't find it, right? It gets a key error. It says, hey, this isn't a thing that we can find. What if I looked at the row that uses the value 3 here for its pandas row index? Would I be able to find something? Yes, in that case, I can actually get something 329.2, but you'll notice that calling with LOC and .iloc on a filtered data frame uses very different numbers here in order to get the same piece of information. Another thing that we can do in order to make sure that .loc and .iloc work the same is after we've filtered our data frame, we can reset this row index over here using the reset index method, right? So I'm going to reset this index and I'm going to save it over to the variable name df. So we're going to create a new variable here. And you'll see that these row indices got reset. So now that I have reset the index on my filtered data frame here, let's make sure that .iloc and .loc now do work the same way now that we have kind of a more normal index here. It doesn't skip any values. It just starts at 0 like we would expect when we read in a brand new data frame. So I'm going to add a code cell here, and I'm going to say df.loc. I'm going to grab row 1, column 3, 525.32. And I'll do the same thing with iloc, 1 and 3. And you'll see that now we've reset the index. They do indeed grab the same value because the index position is the same as its literal position in the data frame, whereas with the filtered data frame without the reset index, the index on the left-hand side here was not the same as the literal position of the rows and columns in the data frame. So that's just a quick reminder about how we can filter a data frame, and after we filtered a data frame, be extra careful about the differences between the iloc and loc methods and how they help us to grab subsets of our data frame. Now typically, when we work with index values, we will let pandas assign those integer values to represent the individual rows. We want something unique for each row so that we can grab a specific row based on this bolded value on the left-hand side. But you'll notice for my sales data set here, I don't have any months that get reused. So I have a unique set of months. So I could, in theory, and this might be a wise thing to do actually, use the month markers here as my index. So what I'm going to do is I'm going to tell my data frame, hey, data frame, don't use the row values here. Let's use the month column as the index on this data frame. And again, we'll do this in place to make sure that we change our sales data frame itself. And what this is going to do is it's going to treat the month now as our index. So at this point, we can really show the differences between .iloc and .loc. So let's say sales.loc, and let's grab 1, 1. And cannot do label indexing on class blah, 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 blah with these indexers 1 of class int. Why is LOC not working here? Well, because my index here is no longer numeric. What if I said Feb? Well, then I do actually get the value I would expect to here in February for the value of shoes. Now, if I do .iloc, I can just use the index values themselves. But if I try and use the row index, you'll notice I do now get an error, right? So .loc, what is it doing? It's using these bolded values as its row indicator, and then the position, the index position for columns. .iloc is using just the literal index position for both. That's why it's the index location method rather than just the location method.